All right, so today we are going to talk about section 7.1, propositional proofs, and what is called the indirect proof or the reductio ad absurdum strategy. So that's what we will focus on today. All right, so here's a proof in natural English language. The only people, given that the only people in the mansion were the butler and the maid, and if the only people in the mansion were the butler and the maid, then the butler or the maid did it. And if the maid did it, then she had a motive. But the maid didn't have a motive. From those four claims, it is possible to claim that the butler did it. Now, Gensler, frankly, is a little bit enamored with what is called the indirect proof strategy or the reductio ad absurdum strategy, which is what the abbreviation RAA stands for. And here's how it works. Anytime you are doing a proof, you are actually allowed to make any assumption that you want, as long as you block it off and separate it from the main proof. And what the goal of adding any assumption that you like is to show that that assumption leads to logical absurdity. Logical absurdity isn't, logical contradiction or absurdity is a very specific thing. And people, frankly, use the expression in broader culture very loosely, not really understanding what contradiction is. What a contradiction is or absurdity is, it is not a conclusion that's obviously false. It is not a conclusion that I think is unlikely. A logical contradiction is something like this, where I claim that A is true, and elsewhere I claim that A is false at the exact same time, in the exact same way, in the exact same sense. That is what it means to have a logical contradiction, a logical absurdity. So the indirect proof works by adding an additional assumption that we are going to make, and the goal is to prove that the assumption leads to absurdity. And once you prove that the assumption leads to absurdity, by indirect proof rules, you've actually proven the opposite of what the extra assumption was. So basically, in indirect proof, you make an assumption in order to prove the exact opposite of the assumption. So step one is that you can add an additional assumption to the proof meant to be refuted. Once you make the assumption you wish to disprove, you need to draw upon the combination of that new assumption and all the already existing assumptions to derive this direct logical contradiction. And it doesn't have to be something simple like A and not A. It can be something like, if A, then B is true, and is not the case that if A, then B is true. This is also a logical contradiction. Any exact phrase, simple or complex, that is both affirmed and denied is a direct logical contradiction. So once you make the extra assumption that you wish to disprove, you draw upon all the given assumptions to try to get to that logical contradiction. And once you derive a logical contradiction, you then conclude the opposite of the initial assumption. So if I started with the assumption, if I added the assumption B, and I did a bunch of inferences, and I got if A then B, and it's not the case of if A then B, then the conclusion is the opposite of this initial assumption. The conclusion would be not B. So whatever you assume, the goal is to get a direct contradiction, and conclude, infer the exact opposite of this assumption. Now, this has a real nice application to proofs if I give you a bunch of assumptions and I tell you the goal of all these assumptions is to prove, let's say I said the goal of all these assumptions is to prove A. Well, guess what? The way to prove A is to start by assuming not A, blocking it off, using all the indirect proof tools that we will discuss, getting a direct contradiction, and then once you get that direct contradiction, you conclude the exact opposite of this initial assumption. So that's the 30-second version of what we're trying to do. All right, so let's use the indirect proof strategy with this story about the butler and the maid. Of course, in sort of very old murder mysteries, the butler is always the one who did it. It's one of the writing cliches, and this is what the joke here is about. But so here are the 4 premises we're given. First, the only people in the mansion are the butler and the maid. If the only people in the mansion are the butler and the maid, then either the butler or the maid did it. If the maid did it, she must have had a motive, but the maid did not have a motive. All right, so what does this look like if we are going to try to use the indirect proof strategy to prove from these premises that the butler must have done it? All right, so steps 1 through 4 here are the assumptions we've already discussed. But what we add is step 5. We've added the assumption for indirect proof, RAA, reductio ad absurdum, and indirect proof. We add the claim that is the opposite of the conclusion we intend to prove. We intend to prove that the butler did it, so we will assume that the butler did not do it. When we assume that the butler did not do it, we can then look at statements 1 through 5 and see what kind of inferences we can do. And if we look at statements 1 and 2, statement 2 is an if-then statement, an arrow statement, if we translate it into logic. And statement 1 affirms the left side of the arrow statement. That is statement 2. So statement 2 says if the only people in the mansion were the butler and the maid, then either the butler or the maid did it. And the first statement was that the only people in the mansion were the butler and the maid. So you plug statement 1 into the if-then statement of statement 2, and you derive out that the butler or the maid must have done it, which is what statement 6 is. So we've used 1 and 2 to get 6 using the left to right modus ponens arrow rule. Then we keep looking at the statements we've got. We might notice that from statement 5 and 6, statement 6 is an or statement. It says either the butler did it or the maid did it. It's an or statement, a wedge statement. And statement 5 denies one of the halves of the or statement. Statement 5 denies that the butler did it. So therefore, statement 7 is inferred from statements 5 and 6 using the or rule, also called disjunctive syllogism. And we conclude that the maid did it. Or rather, we infer that the maid did it. Now that we've got 7, we can plug 7 into statement 3. Statement 3, again, is an arrow statement, an if-then statement, which claims if the maid did it, then she must have had a motive. And number 7 suggests that the maid did it. So we plug statement 7 into the left half of the arrow statement, that is statement 3, and we derive that the maid must have had a motive. That is what we infer out in statement 8. But look, once we get to statement 8, we then have a direct logical absurdity. We have a direct logical contradiction. How do we have a direct logical contradiction? Well, if you look at 4, 4 says the maid does not have a motive. And 8 says the maid does in fact have a motive. That is a direct logical absurdity. Both of those claims cannot be true. One of them has to be incorrect. Therefore, what we've shown is assuming in statement 5 that the butler didn't do it, we get the direct logical absurdity that the maid both does and does not have a motive, and we are entitled to infer out the opposite of the assumption in statement 5. So instead of the butler not doing it, we instead conclude the opposite, that the butler did in fact do it. Bam. There we go. Questions? Observations? Now, one thing I don't particularly like is I feel like teaching people to do everything by indirect proof, which frankly is what the book does, I think it encourages you to make arguments and proofs more complicated than they actually have to be. So if you look at this, you actually could have succeeded in proving that the butler did it just using the basic rules of inference without using the indirect proof strategy. So what you could have done is you could have used 3 and 4 to prove that the maid didn't do it, because 3 is an arrow statement and 4 denies the right half of an arrow statement. You could have used 1 and 2 to derive that the butler or the maid must have done it. And you combined that the maid didn't do it from our first inference with either the maid or the butler must have done it. And you could have used the or rule to prove that the butler had done it. And that would have been about 2-3 steps quicker. So honestly, I actually like to use the strategy we used last time whenever we can. I don't like, as I confessed to you many times, I'm actually quite lazy. I don't like making extra assumptions, doing extra work when there's simpler ways to do things. But here's why Gensler advocates the indirect proof strategy. There are times that the indirect proof strategy will work, and there's no other way to get to the proven conclusion than to use this. So it's a more complicated strategy, but it's a more powerful strategy. That's why we use this as sort of our default move. Does that make sense? All right, let's do another look at this proof, and this time I will use the propositional logic translations so that you can see just in the simplistic logic, in the artificial language of logic, what this looks like. Statement 1. The only people in the mansion were the butler and the maid. T. If the only people in the mansion were the butler and the maid, then the butler or the maid did it. If T, then either B or M. If the maid did it, then she had a motive. If M, then H. But the maid didn't have a motive, not H. Therefore, from this we can prove we will attempt to prove that the butler did it. We will attempt to prove B. All right, so let's get rid of the English language and look at just the propositional logic. So we are given statements 1 through 4, T, and if T, then either B or M. If M, then H, and not H. From that, we seek to prove the next bullet point, B. The indirect proof strategy tells us when we look at proof, what we always want to try to start with is assuming the opposite of the conclusion. By assuming the opposite of the conclusion, then deriving a direct logical absurdity, contradiction, we can then infer out the intended proven conclusion. It's a very powerful strategy. So after we have assumed the opposite of the conclusion, first we do the inference from if T, then B or M, and the claim T. From that we can get statement 6, B or M. From the assumption 5, not B, and the inferred statement 6, either B or M, the butler or the maid, we can infer statement 7 that the maid must have done it. And then once we have the maid must have done it in statement 7, we can plug that into statement 3, if M then H. So from if M then H and M, we get H. But then once we get H, we can look at statement 8, and we can look at statement 4, and guess what? Statement 4 says not H, the maid doesn't have a motive. Statement 8 says the maid does in fact have a motive. That is a direct logical contradiction and absurdity. Therefore, once we realize that, we can cite that and infer the opposite of our assumption. So from not B leads to an absurdity, therefore we will conclude B. Bam. There you have it. All right, how are we doing on that? Let me see thumbs up. Thumbs up if you got it, thumbs down if you don't got it. Yeah, 2 thumbs up if you've really got it and you're kind of getting bored. Wavering thumb if you're not sure. All right, so we're still struggling. Yeah, most of us have it, but a couple of us still have questions. Questions. So what is unclear, those of us who aren't solidly on board? Yes.
So do we have to do it in the exact way you do it, or is there sometimes other ways to get to it?
Excellent question. We are getting to the point in the class where there will be multiple correct ways to do these things. So you do not have to do things in the exact order. So for example, you might have, let me see, what might you have done? Is there something here you could have done in a different order? So yeah, here's something you could have done. You could have done an inference from 3 and 4 and got not M, which we didn't do, and that would be a valid inference. Now, it turns out that that is a logical dead end. It doesn't actually end up helping you. But a lot of times there's going to be either rabbit trails you can follow that are valid inferences that don't really advance your proof. Other times there will be multiple paths that get you to the conclusion, and it's just a matter of which path you want to take, and some are shorter, some are longer, or some are just a matter of which order you want to do them in. So, this is why this is the part of the class where I say we're becoming sort of grown-ups. I mean, the grown-up way of looking at the world is there's lots of ways to do things, and sometimes multiple ways are correct. Some are a little more efficient, some are a little less efficient, but there are multiple correct ways. That being said, despite the fact that there are multiple correct ways, there tend to be an infinite number of wrong ways to attempt to do this. So back to your question, no, it does not have to look exactly like this, so long as you are consistently applying the S and I rules. Good question. All right. Well, here, just to make your lives harder, let me give you a couple more S rules. I don't think we use double negation anywhere, but just in case it ever comes up, not a proposition is the same as affirming a proposition. Just like a double negative in grammar or multiplying two negative numbers by each other, equals a positive number. So a negated negation is actually an affirmation. So this is a bivalent sense of truth. So if I say I think the butler is not guilty, that is actually a very strange way of saying that I think he is guilty. Then we have two S rules for triple bar and negated triple bar. So we did not give you all the possible S and I rules last time. So here's one more ball to juggle in our logical table. The two S rules, I think the first S rule is pretty easy. P triple bar Q is actually the same as saying if P then Q, and also if Q then P. Which is why there's actually some logical systems where this symbol doesn't exist and instead they use a double-sided arrow. So whenever the book uses a triple bar, I actually see this. Because you can infer out if P then Q and if Q then P. Now, I think that's the easier of the two. I think the more difficult one, that's a little harder to remember, is negated triple bar. And I think you're just going to have to memorize this. Or for some of you, I mean, if you follow the abstract logic of this, this makes sense, but it's a little harder. It's a little bit of a more difficult nuance. Negated triple bar means either P or Q, one of the sides is true, but not both sides are true. So triple bar is the claim that they match. Negated triple bar is the claim that one side is true and one side is false, that they don't match. And the verbose logical way of saying that is either P or Q, but not both P or Q. So memorize those. That will appear on the exam. You'll need that for something. All right. So here is, in a certain sense, a very strange proof, the strangest thing we've done so far. This is a proof with no given premises. A proof with no given premises is called a definition. So this is a proof of the claim if both A and B, then A. And you are given you're given nothing. So the idea is prove this claim, prove that from both A and B, A must be true using the tools of logic, but without being given any starting premises. And this is why I said earlier the indirect proof strategy is powerful. Because without the indirect proof strategy, if I'm given this, I can't do anything. But from the indirect proof strategy, step one can be something like this. I can start by assuming the opposite of the conclusion. So if I'm trying to prove that from both A and B, A follows, I start by negating that claim. So that's my first statement. My second statement is to use NIF, negated conditional rule. Remember, there's an S rule from negated conditional rule. Anytime you have a negated conditional, you may infer out the match, the affirmation of the left side of the arrow, and the opposite, the negation of the right side of the arrow. So from the claim, it is not the case of if both A and B, then A, I get both A and B for statement 2, and I get not A for statement 3, both from negated conditional. Once I've got that, then I can look up at 2 and say, hey, from both A and B, I can get A, and I can also get B out. But I realize I don't really need the B. Once I pulled the A out, then in statement 4, then I can conclude using the indirect proof RAA strategy, since denying the conclusion implies that both A is false and A is true at the same time, I may infer the truth of the intended conclusion. I may infer that if both A and B, then A. From our starting assumption in statement 1, because from statement 1, statement 3 contradicts statement 4. Yes. How did I get 4? I got 4 from 2. 2 is an and statement. Both A and B are true. 4 is just half of the and statement. So up to this point, I've always shown you to do both inferences to grab both halves of the and, but you don't actually have to. And that would just be extra space. So if I did statement 5, B, from 2, that would be just as correct. It would just be slightly longer. Yes? I'm going to encourage you to use the rule or the symbol. I'm not going to take points off if you don't, but my experience is people that don't know how to cite people who don't cite the rule just do worse, because and they're harder to grade because it's harder for me to get inside your head and know what you're thinking. So I won't intentionally take points off for not citing a rule, but it's easier to give you partial credit if you cite rules. And in my experience, the students do better if they're in the discipline of using the rules. So I'm not going to require it, but I'm going to strongly encourage it. Good question. Yes? Yeah, so the final is comprehensive, which means it will cover everything from day 1 until the last day of class. And in part, it is comprehensive because I'm trying to be gracious. Because there are usually about 20% of the class that has no freaking clue what to do with this section. And they leave the proofs blank. Or maybe they remember, assume the opposite of the conclusion. And if I only did, post exam 3, those people would get zeros on the final exam, and that would be devastating. So because I'm trying to be gracious, I have to have a disproportionate part of exam 7 focus on this stuff. But you will also, draw upon the skills from chapter 1. And generally, so I know that gives you more to study, but I think on the whole, the class does better. All right. Let's try this. Let's look at this one. P, if P, then B or M. From P and if P, then either B or M, you can get B or M. From M, you can get O, but not O is given, so you can get not M, and therefore you can derive out B. And this is the, again, this is the logic of the butler and the maid English proof, but this is what it looks like without using an indirect proof. So if the people, so one, if the people at the mansion or the butler and the people at the mansion or the butler and the maid, if the people at the mansion or the butler and the maid, then either the butler or the maid did it. From 1 and 2, you can get 3, the butler or the maid did it. 4 is given. If the maid did it, then she must have had a motive, but she did not have a motive. Therefore, the maid did not do it. Since the maid didn't do it, and either the butler or the maid did it, then the butler did it. So this is me doing the butler and the maid proof without using the indirect proof. It's a step or two shorter. All right, let's do one together. And I'm going to do it on the board, and I'm not going to just put the whole thing up on the screen. Let's do from if A, then B. Let's prove that if not B, then not A. So from if A, then B, our goal is to prove if not B, then not A. All right. So what do we do first? What do we do first? Good. We want to assume the opposite of the conclusion. So the intended conclusion we want to prove is if not B, then not A. So we're going to, for statement 2, we're going to assume it is not the case. If not B, then not A. And that is an assumption intended for RAA proof. We're going to block this off to keep track of the fact that we are now working off of an assumption. What do I do next? Somebody help me. What do I do next? Yes, sir. Good. So I'm going to use the NIF rule, the negated conditional rule. I'm going to use it on statement 2. And I'm going to derive out the match of the left side, not B, and the opposite of the right side, which is affirmative A. Both of these are from statement 2. NIF, negated if then. Okay, what do I do next? What do I do next? You in the red. Good. So yeah, when doing a blocked off subproof, you are allowed to reach back into the given material and use the given material. So we've already did NIF, so we're probably not going to use this again. These are just simples, so we can't really derive anything from them alone. So we've got to stare at this. As has been suggested, I can use the arrow rule 1 with statement 3, and that can get me not A from 1 and 3. That's called the MT arrow rule. And then once I've done that, I then have a direct contradiction because I've got A true in statement 4, but I also have A false in statement 5. So therefore, I can immediately prove the opposite of this assumption and derive if not B, then not A from 2, because 4 and 5 contradict. No, I saw your hand, yes. Absolutely. And that would be 100% equally correct and equally efficient. So instead of doing 5, getting not A, you could do this. You could plug the A from 4 into 1, and you could get B. And that would be from 1 and 4. And instead of the MT rule, that would be the MP rule. And instead of 4 and 5 contradicting, it would be 3 and 5 contradicting. So this is what I was talking about earlier when I said there's more than one right way to do it. Both of those are excellent, equally efficient, equally correct, 100% full credit, either of those two ways. All right, let's do another one together. From A, let's prove either A or B. All right, so we're given A, that's statement 1. And we're going to try to prove all right, what do we do first? Yes. Good, so we're going to assume the opposite of the intended conclusion. So we're going to block this off. Statement 2 is going to be, it is not the case of A or B. Neither A nor B. That's an assumption for indirect proof. Good. What do we do next? You got it? You got it? Oh, yes, you got it. Good. So we could use the negated or rule, and we could get not A. And if we wanted to, we could also get not B from it. So that's from 2, negated or, sometimes called nor. And as soon as we write not A in statement 3, we then have a contradiction because we have A true in line 1, A false in line 3, and we can infer that either A or B must be true from line 2 because 1 and 3 contradict. Easy stuff, right? Good. Good. We're coming right along. All right. What else do we need? Maybe I should jump ahead to a hard one. Let's do this. All right. From A or B, if A, then C. And if B, then D. We want to prove either C or D. All right, so step one, we always start by assuming the opposite of the conclusion. The intended conclusion is either C or D, so we are going to start by assuming not C or D. Then I'm going to look at 1, 2, 3, and 4, and I'm going to ask, can I do any S rules? And I can use an S rule on 4. From 4, I can get 5 and 6. I can get not C, and I can get not D. That's from negated or, NOR rule from 4. And then one thing that's not part of the method, but I just do for myself, is I usually put a little check or a little X next to something that I've used. Now, there's no rule that says you can't use it more than once, but usually you will use each complex statement once. All right, so I've used 4. 5 and 6 are simple one-letter statements, so I can't do anything with them by themselves. So I'm going to look up at 1, 2, and 3. I can't do anything with 1, but then I've got a choice. Do I want to use 2 with 5, or do I want to use 3 with 6? So I'm just going to go sequentially. I'm going to use 2 with 5. 2 with 5 lets me do if A then C, but not C. So I get not A using the 2, 5, MT arrow rule. And then I put my little X next to 2. All right, so I've used 2, I've used 4, 5, 6, and 7 are simple one-letter statements. So I need to focus on either 1 or 3. And here I'm going to work with 1 because, like I said, I'm going to work sequentially. It's not a requirement, it's just my preference. So 7 says not A. 1 says A or B. So from not A and A or B, I get B. And that's 1 and 7, and that's the OR rule, DS. All right, so now I've used 1, 2, and 4. 5 through 8 are simple one-letter statements. That makes 3 stand out like a sore thumb. There must be something that I should try to use 3 for. 3 says if B, then D, and I just conveniently have a B. So I will do step 9. I'll plug that in, and I will get B. From 3 and 8, and that is the MP arrow rule. And once I've got D in step 9, I realized that back in step 6, I said not D. So 6 says D is false, 9 says D is true. That is a direct logical absurdity, which demonstrates that the opposite of not C or D must be the case. So statement 10 is C or D, which was to be proven. It is from the line 4 because 6 and 9 contradict. And there we go. And this, frankly, is the level of proof. You know, this is kind of like the starting level of proof. So, you know, this, if you're comfortable with this level, you're doing pretty good. If you're not comfortable with this level of proof, work on it until you're comfortable with at least this level of proof, because something that looks like this will appear on the file. Questions? How are we doing? Yes. It's common to use every complex statement. It's not, again, it's not a necessity. It's not a hard and fast rule, but you know, usually, you know, we're not yet at the point where I'm trying to give you red herrings. I'm just, you know, giving you 3 statements that you'll never use. So, you know, usually at the level that we're working, if you haven't used something yet, try to find a way to use it. But, you know, I mean, sometimes you can use one statement more than once, especially if you can use it in like an error with, you can use it with an error statement one time and then with like an or statement another time, if you have the right statements. But, again, when I do this, I always look for S rules first, because S rules give us more raw material to work with. And then I just look sequentially, and I just kind of give myself little tick marks to keep track of which ones I haven't used yet. And that works pretty well. All right, well, if there are no further questions, for next time, 7.2, refutations. So today we showed you how to prove that something follows from a certain set of claims. Next time we will demonstrate that a certain conclusion does not follow. Something is not implied by a given set of claims. Thank you very much. See you Wednesday. The end is near. Sure. That is the expectation without special permission.
Okay, I was wondering if I could do it at my house because after me, I just and I have 2 more things after it, and they're each like 30 minutes apart from each other.
Now, one thing you should consider is you can request to have an exam moved if you have 3 in a day.
Okay.
That might be a better option for you.
Okay, I'll try that. Thank you.
Yeah, so good. So if you want to move this exam, just let me know, and I can have you take it with my noon class.
Okay, I'll see what I can do. Thank you.
I got the other day, I'm leaving campus.
Yes,
And it's this time, the 20th.
okay.
So with the homework journal, you want me to try and try it?
You know,
I'm like at 7.3 now, because my job is just sitting and calling.
nice.
It's a lot. We don't work.
Well, why don't you do this? Why don't you keep your homework to study off of?
Okay.
I will probably, I mean, I assume you wrote it out and you didn't do it on a computer file.
Right.
What I've had people did since COVID is I've had them like take pictures of certain homework assignments and just email me the photos of, so I'll pick like 3 or 4 assignments and say, send me the pictures for these 4 assignments.
Okay, thank you, yeah.
Yeah.
That works.
Are you one of our majors?
Yes,
Excellent.
yes. I'm double majoring in philosophy and.
Excellent. That's a very powerful double major. Do you want to go to law school?
No, I want to work at an international NGO. I
Nice.
thought philosophy with critical thinking would boost my chances of getting it, because the one that I want to get in is hard to get to.
Well, I mean, let's be blunt. Speaking as someone who had a political science major and a history major, but not a philosophy major, political science majors are kind of a dime a dozen, and history majors even more so. But a combo political science philosophy major, that will make you stand out, especially if you're tracking on this well enough that you can get to 7.2 and 7.3 without my help. I mean, you're getting some advanced skills there. That's good.
Yeah, this chapter has been like super easy for me.
So here's what that communicates to me. That tells me you are a good abstract STEM style thinker. So you must be good in things like calculus and physics if you want to.
No, I'm not gonna do it.
Really? You see, I bet you would be if you wanted to, because this uses the same kinds of skills. So usually the people who do best in this course are physics majors and math majors, not philosophy majors. Some philosophy majors really struggle because they're used to reading a bunch of stuff and then spouting off their opinion. And the idea that there's rules that they have to follow, and that's very difficult for some of them.
I can get it in math,
Yeah.
but not like, I did 3 calc in high school.
Mm-hmm.
That can go well.
I mean, let's just say this: I wouldn't bet against your STEM skills if.
Oh, I have good STEM skills.
Yeah.
Math is when I need calculator.
Yeah, that's what calculators are for. And I could be good at stuff like that, but I find it to be immensely boring. So
That's probably why. Like math, I find immensely boring. And like, repetitive here, I'm like translating sentences at least. So it's not at all